Hi everyone, so welcome back to my channel and let's start with today's Leetcode challenge, that is cousins in binary tree 2. Until now we have completed 12 challenges. In case you have missed any, you can watch it on my YouTube channel. I've created a playlist for the same. And let's quickly start with today's question. So we are given the root of a binary tree and we have to replace the value of each node in the tree with the sum of all its cousins values. And the cousins are two nodes of a binary tree are cousins if they have the same depth with the different parents. And after that we have to return the root of the modified tree. So I think we have to do in place. Okay, just quickly go through the example first. So we are given this tree 5 4, then 1 and 10, and 9 and 7. So we have to do it like this: 0 0 0 and 7 7 11. How it is? Because 5 has no cousin, so it will be 0. 4, for this there is a cousin 9, but they have same parent, so it will also be 0. So both of them are 0. For this one, the cousins are 10 7, but the 10 is not a cousin because they both have same parent. So now its value will be only 7. Okay, if there's some value on the left of 7, then we will add both of them and do it. Same for this 10, because 1 is also immediate sibling, so it will not add it, but we will add 7. So here will be 7 for this 7 value. So he doesn't have any immediate sibling, so 10 plus 1 is 11, so it will be replaced by 11. Similarly we will do, but here if you see example 2, since 3 is a root, so it will be replaced with 0. 1 has an immediate sibling and no other cousin, so it will be 0. Similarly 2 has an immediate sibling 1 but doesn't have any cousin, so it will be 0. So like this we have to do it. So let's just move to the intuition building part to make it more understanding. Yeah, so let's just start with the intuition building part. So as we have discussed in the last question, for going through any of the tree questions, you generally have two options, either through DFS or BFS. DFS, as we discussed, it's going to the depth first and then coming back, and BFS is generally doing your work at first level, then going to other level by level. So that is BFS, and DFS is depth going and coming back. So now what we have to do, since we know that if what is the answer for this, let's just do that first. So the answer for this will be like here 5, since it has no cousins, so it will be replaced with 0, right? Now we come to 4. 4 has a neighbor, but it 4 has a cousin, no, because they both belong to same parent, and if they both belong to same parent, then there will be no cousin. So in the real world also, like, they are not cousin, they are siblings. So the sibling sum is, if you see, 13, right? And now for this 4 will be 0, and for similarly for 9 it will be 0. But now you see, now we will get our answer, because if you see directly that after the level 1, if you see, this is level 0, this is level 1, this is level 2, then after level 1 only, then we will get our answer. Before level 1 and at level 1 we will not be able to get an answer anytime, right? Because they will belong to the same parent every time, and root has no parent of itself, so they will surely be 0 0. And after level 1 only we will get, because at this point of time they will have different parent. Okay, since 1 and 3 have different parent, 10 and 3, 10 and 7, 1 and 7. Okay, so now you will check 0 0. Now for 1, 10 is its sibling, so we will not add it, but 7 plus 3 is 10, so we will replace it by 10. Okay, because we have to replace by cousin sum. Basically these two are cousins, the sum is 10. Now for 10, again this, right? We will not add 1 because these are siblings. Okay, we have to check this. We don't have to add, we should not add the siblings value, we should only add cousins value. For this 3, 7 will not be added, but 11, so this will be 11, and again this will be 11. So if you see that, we have to always check that it is not a sibling and we just have to add the other values. Now we can see directly that what we are doing for this one, which values we are calculating. This 7, this 3, we are just skipping the one. If you take another example for more levels, now let's just say 5, then 2, then 3, then 6, 8, now 1, 4, again one level more. So it will be, let's just say 9, again 1, again 12, 15, and this has no child, but this has 2. So it will be 12, and this will be 11, right? Now see, so again we have discussed that it will be not it has no name cousins, it has no cousins, so they will be, answer will be 0, then 0 and 0. Now from this level we will start making our answer. So for this level, if you see 6, 8 is a sibling, so we'll not add it, but 4 plus 1 is 5, so 5 here, again 5 here, right? Now for this one, 6 and 8 are cousins, but 4 is not, so it will be 14, and similarly 14, right? Now for the next level, if you see this is cousins, and this also cousins, but 1 is not, because the immediate parent is 6. So for this 9, what is the sum? 15 plus 12 plus 12 plus 11, so it will be 50, right? Similarly for 1, it will be 50. Now for this 8 child, 12. Okay, for 12 we don't have to add 15, but what we have to add, this 10 and this 23, so it will be 33, for this 33, right? 1 has no, so nothing, but 4 has these two, so for these two what will be the values? 12 and 11 will not be there, but all of them on its left side will be there, so it will be 37, and it will also be 37, right? Now what the pattern we are seeing, except for first, let's just say this is the 0th level and this is first level, so for 0 and 1 we are not doing anything, but from third level what we are seeing, except for the immediate sibling, we are adding all the values on the other uh, level, so of the same level, so 1 and 4. So what we are observing, that we are doing somewhere level sum, right? This is somewhere level sum kind of thing. So if you see 4 plus 1 is 5, if you just add 8 and 6, so it will be a level sum for this, but we have to skip the same siblings, so 8 and 6 will be skipped, we just have to add the other ones. Similarly for this, if you are seeing, all the values are added, so this is level sum except for the current and its immediate sibling. So we have to devise some way to skip the current sibling and subtract the current value from this level sum, so that we can get directly our value. So this thing we have observed. Now we will do our logic building. So let's just take the same example. So now we know that our approach would be similar to level sum, and in the last question we have done the level sum, so I think most of us know about that. In case you have missed, you can watch it on my YouTube channel. uh, I've created a video where I've calculated the level sum. So we know level sum, how we will calculate, using BFS. Using BFS, we calculate level sum. Okay. Now for each level we have values. So it will be 5, it will be 13, and it will be 11, and 10 is 21. So we have all this, and we have a, let's just say we have an array. Okay. 5 is here, 13 is here, 21 is here. This is first level, second level, and this is third level. Indexing is 0 based, right? Now what we'll do, we will, let's just do a dry run. So now we will come to 5. We know for this 5 we have a level 0, so we'll not do it, we will just directly do 0, right? Now when we basically you do BFS, what we generally do, we process the current node and add the left and right to a queue, right? So what we will do, you will use BFS. So you process the current node, right? Current node is already 0 because this is root, so we have already done the value for that. Now we will process left and right. Okay, so this left is 4 and right is 9. What you have to do, if you have to modify this value, what you have to check, if there is any right. So for 4, what you have to check, if you have left and right, you will add those value first. Okay, so 4 plus 9 is 13. Okay, now what you will do, for this 4, what you have to subtract from the level sum, the sum that you have got. Okay, because this is a sum of the left and right both. So for this level, what you have to do, you have to subtract, this is level sum, this is level sum, you will get this, and this is your sibling sum. We'll write it like sibling sum is 13, right? So for this 4, when you process this, what you have to do, current level sum is 13, so 13 minus sibling sum is 13, so it will be 0, so you will replace it with 0. Now you come to this 9, again same process. So sibling sum is 13 and your level sum is already 13, so you will replace it by 0. Now you come to this one. Okay, what you have to do now, for this one you will check your level sum is 21. Okay, and your sibling sum is 1 plus 10, that is 11. Now what you have to do, you have to subtract 21 minus 11, that is 10. And I think you got your answer because 10 is sum of these two. These two are cousins of 1, and similarly for 10. So when you process 10, what you will check, you will get your level sum. So for this 10, level sum is 21 and your sibling sum is 1 plus 10, that is again 11, and subtraction value is 10. So you will update the values, this with 10 and this with also 10, right? Now you come to 3. For 3, the sum of siblings, so sibling sum is 3 plus 7, that is 10, and your level sum is 21, so level sum minus sibling sum. So if you subtract the sibling sum, you will get all the values that are not the siblings and they are called cousins. So you will get 21 minus 10 is 11 and this is also 11 if you see in the original tree. So you will replace it by 11. Now for this 7, what is your sibling sum? Sibling sum, if you see, 7 plus 3 is 10 and 21 minus 10 again 11, right? So you have to replace it by 11. Now what we are seeing, we are processing this, right? But we have to process, we can process one node at a time. So if you process this value and you will update while going to it, so now your value is 11, and when you calculate sibling sum, you will not get 3, you will get 11. So what you have to do, you have to process both the nodes at one time, right? And one more thing, so if I do it like this, 3 and 7, earlier it was 3 and 7. Now when you come to 9, okay, how you know that 4 is your sibling? You either have to maintain your parent so that you can get your direct sibling, or what you can do, when you are processing 5, right? when you are at 5, you can directly update 4 and 9. How? So let's just say your current node is 5, right? Now what you will do? You will check. So now what you will do? You will check if you have any left. So current node left, if it is there, if current node left is there, yes, it is there. So sibling sum plus your current node left value. Okay, so sibling sum you have calculated. Similarly, if current node right is present, you will add sibling sum plus current node right value. Okay, now you have sibling sum for 4 and 9. What you have to do? You will process them. How? If your left is there, current node left is there, right? That means this node is present. So what you have to do? You will do your work. You have to add it in your queue, that is BFS. So you will add current node left, right? You have added, and you will update your value. Current node left value. What is the value? Level sum. So current level sum is 13. So 13 minus your sibling sum, and sibling sum is 13. So you will have your value, right? So this is how you should process. If you are at this level, let's just say this is 0 level, then you will do your work for next level, because when you come to each level, you don't have your this sibling directly. You either have to access through it parent, or there is no other way directly. So what you can do, you will do pre-processing. This is called pre-processing, right? You are pre-processing for the upcoming nodes, so that you don't have to worry when you come to these nodes. Because one more thing, why it is happening. So when you come to this 3, what was your basically sum on its neighbors, cousins? So it is 11. So now you say you replaced it by 11, right? Now you come to 7. What is your sibling? Sibling, if you see in the modified tree, it is 11. And if you subtract level sum with your sibling sum, 11 plus 7, that is 18. You get your 3. But 3 is not the sum of its cousins. So this is how you will get your answer wrong. So that's why you have to do this pre-processing, right? So I think we are good on this approach, and while doing the code we will do it and understand it better. But the most important step are BFS we will do. That is a one thing, that is a prerequisite. Okay, if you have not uh, aware of this, you can watch it in my previous video. I have like explained BFS approach, the same approach we will use. And similarly, level sum using BFS, right? So these two are prerequisites. You can watch it on my last video. And in this question, the two steps are: first is level sum, then pre-processing. Now we come to point of time complexity and space complexity. Okay. Okay. So now we will talk about time complexity and space complexity. Space complexity is directly what is we will be using for this BFS. Since we will use this BFS, so it is queue, and at max the queue will store maximum number at each level. So let's just say it will store the n nodes, because if it is there only one level, then at max it will store the n number of nodes. And similarly, time complexity we will be doing, as we have mentioned, first we will do BFS and calculate the level sum. So yesterday we had discussed, so level sum will be big of n, and after that what we'll do, we will do this pre-processing, again big of n. Okay, so it is equals to big of 2n, and somewhere it is called only big of n, right? And this is the good time complexity, okay, for this approaches. Now we will go to the coding part to make it understand more. Okay, so we can quickly start the coding part. So what we need, first we need a queue, okay, for traversing breadth first search. So we have the queue, so we can write calculate level sum using BFS. Okay, so we require a queue and we require a vector of long type for storing the level sum. Okay, so it will be level sum store. Now we will add the root in this queue, and now we will do the BFS. So this is a generic BFS code while queue is not empty, and we will get our size. I've done the similar code in the last video, you can check it out and explained there also. So we will get our size, and now what we'll do, we will need a one variable for calculating the level sum, long level sum. Initially it is 0. Now we will go while size minus minus. First we will get the top element, tree node q dot front. Now remove it from the queue, right? Now add the value to the level sum equals to node value. Once done, we will process the child node left. Then we will do q dot push node left. Similarly, we will do the right part. So it is node right and right. So we have done this. When we come out of this loop, we just add the level sum. So this level sum store dot push back what we have to add level sum, right? This is we have calculated. Now update the tree with modified values of cousins, right? Now what we have to do, first we have to add the root value, okay, because we have to do processing. Now what we have discussed, root will always be 0, so root value will be 0 because root can never have cousins, so it will always be 0, right? Now what we have to do, we have to have some level how to get directly from this levels sum. So level will be first, because the indexing is 0 based and we have to like pre-processing. So pre-processing will be when we are at this root, so we have to process for 4 and 9. So when we are at 4 and 9, we have to process for 1, 10 and 7. So level must be 1 greater than the current level, and this is 0, so this will be 1, right? So level is 1. Now we'll do same BFS q dot empty and again size q dot size, right? Now what we do, first we have to get the current level because we are getting the level. Similar approach here. Now we have to get the level sum. So long level sum will be, what is that value? So level sum store of level. One thing to observe here, so we will I will tell you later, but you try to observe what we are doing somewhere wrong here. I will tell you later. You just try to do it on your own first. Okay, now what we'll do, we will go in over this queue and remove the first node. Again, right, node equals to q dot front q dot pop. Now what comes? Pre-processing. So pre-processing includes, for every, when we come to this, we have to process for this and this, and for this what we have to check if there is any we have to calculate the sibling sum. Okay, so if there's any sibling, so sibling sum will be the node we are currently on, its left. Okay, we are in the fifth, on the fifth, so 4 plus 9, so node left value plus node right value. So what we have to check here, if we are on 1 and 10, okay, we will be on the 1 and 10, right? For 1 it will give error because node dot left will be null and node dot right will be null. So we can check directly here, node left is present, then we'll add the value, else we will add 0. Okay, and similar we will do for here, node right present, so we'll get the value, else we will get 0, right? Now what we have to do, same thing that we have our, if left is present, then we will update the value, node left value. Now this value will be the level sum, subtract the current sibling sum, right? So level sum minus sibling sum. Okay, similar we will do for right. So this is right, right. Okay, we have done the processing. Now when we come out of this, what we have to update, we have to update the level, we will update. And when we come out of this queue, once queue is empty, we will return the modified root, that is original root only. So what I have asked, so this level sum, okay, if we are on this level, if we are on this node, okay, and it will calculate the size, but the level sum level will be updated. So level 0, 1, 2, okay, level will be 3, but there is no value at 3 index and it will give you index out of bound exception. So what we have to check here, if level is less than level sum store dot size, okay, if it is there, then we can get this value, else what we will get, 0. Okay, right? So I think we are good on this, and now we will try to run it. Okay, we are getting wrong values, so where it is giving, okay, so it is getting 1, 10, 7, same from the above. It is not updating. Why? So we are doing the same good thing here, pre-processing, removing from this. Okay, one thing that we have missed, we are not pushing the nodes. So node left and here node right, as we are doing above. Okay, think this will resolve. Yes, we are good on this. Now we'll try to submit it. Yes, so we have submitted this successfully. Thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications so that you can get notified about other problem solutions. And in case you have any comments, any questions, please do ask in the comment section, or you can ping me on my Instagram. I will add that in the description. If you have any alternate approach, you can share that in the comments. I will review it, and so that everyone will be aware. Thanks everyone.